So today we're going to review just a little bit and actually show you guys how to talk about one reactant and then switch and talk about a different type of reactant or product. And the first thing that you're going to need to do these types of problems will be a balanced chemical reaction. Now this is not balanced, is it?
No.
So let's go ahead and balance this reaction. I see here one zinc, one H, two H's. So quickly I see I need to do what?
Times by 2.
Coefficient here of 2. So now I balanced my H, but I've also affected my Cl. So let's look. Okay, so now Cl is balanced. So this is the balanced chemical equation. Now what you need from this balanced chemical equation is actually the mole ratio. Okay, the mole ratio. And the mole ratio is simply the number of coefficient that's in front of the reactant or the product. So the moles that I have of zinc would be 1 mole because there is a coefficient we know here of 1. The number of moles for HCl would be what? 2. So if I want to know the mole ratio for zinc, let's see our problem. Zinc and zinc chloride, that mole ratio is what? 1 to 1. So I would say 1 mole of zinc for every 1 mole of zinc chloride. Make sense? Well, if this makes sense to you and these are the two in the problem, then you'll see very quickly that this is what we're going to have to use in our problem. So this problem says here, if you start with 2.3 moles of zinc, how many moles of zinc chloride are produced? So just like with any other problem, we're going to start by writing our given, 21.3 moles of zinc. Notice I wrote all of that, my units again. Now I'm going to write my time sign and my line like we did with any other stoichiometry problem. And I see that I need moles on the what? Moles of zinc on the what? Bottom. So would I use it written this way? Moles of zinc?
No.
I'm going to have to flip it over. So I'm going to write my 1 mole of zinc chloride here and 1 mole of zinc on the bottom. Now this problem had a coefficient of 1 and 1, but just imagine if these coefficients had been a 2 here. This would definitely affect your problem. So we see that our moles of zinc cancel out here and we're left with what? The moles of what they asked us for in the problem. So this is how you go from talking about apples to oranges. Okay, you use the what? Mole ratio. So now we actually do this math in our calculator. We don't need one, I hope. 21.3 times 1 divided by 1, our answer is 21.3 moles of zinc chloride are produced. Okay? So now we're going to take a look at a problem that is going to involve not just one coefficient, but a coefficient of more than 1, so you can actually see that this mole ratio affects the problem, and it affects your results. Here we have a new problem. Same balanced equation, right? Same reaction going on in this beaker. And we have this problem now. If you start with 11.2 moles of hydrochloric acid, how many moles of zinc chloride are produced? So again, when we go from talking about apples to oranges, because we're not talking about the same thing here, we must use the what? Mole ratio. Okay, is Anaya the only one in here? No. Sounds like it. So, what would be the mole ratio when I'm talking about hydrochloric acid and zinc chloride? How many moles of hydrochloric acid?
2.
Okay, so 2 moles of HCl, and make sure you write the unit there and the compound.
1 zinc chloride.
Very good. 1 mole of zinc chloride. Now I hear a couple more people. All right. So now we know that this is going to be the mole ratio that we use. We may have to flip it or do something to it, but this is the mole ratio for these two discussed in the problem. So what do we do first? We always write out what first when we solve it? The given. So let's go ahead and write our given number, which is 11.2 moles of what? HCl. Times and a line. Now, moles of HCl up top here, so I need to have it where? At the bottom. How many moles did you tell me of HCl it was? 2 moles of HCl. Now, I already know you're getting those calculators going for me. 1 mole of zinc chloride. Now we have to do this math, don't we? Multiply this number on the top by this number on the top, then divide by what's on the bottom. So 11.2 divided by 2 is going to give me what? That's 5.6 moles of zinc chloride. So now we're going to take a look at what happens when we go from grams to moles. Okay? In the previous videos, we talked about moles to moles. We just used the mole ratio. Simple. But now we have to go from grams of hydrochloric acid to the moles of hydrochloric acid first. And how do we go from grams to moles or moles to grams? What do we use? Absolutely, the molar mass. Okay? So I'm going to go ahead and write my given, which is what? 2.6 grams of who? Hydrochloric acid. I'm going to go ahead and write my time sign. I know I need grams of hydrochloric acid on the bottom. And you're going to weigh that up on the periodic table. Chlorine weighs 35, I think, 0.45. And hydrogen weighs 1.01. So we're going to go ahead and make this what? 36.46, I believe. Check me, make sure I'm right. And we'll put that 1 mole of HCl. Okay? Now, where did this come from again? What is this? The molar mass. Now, we're using this molar mass again to get from grams to what? Moles. So now we're going to use the mole ratio to get us from talking about these apples to talk about the what? Oranges. Okay? So to go from HCl to zinc chloride, I'm going to have to use the molar mass for this. So I'm going to say there is what? 1 mole of zinc chloride. Thank you, baby. For every 2 moles of HCl. And I already wrote it the correct way, didn't I? Yep. So I'm going to put my 2 moles of HCl on the bottom and my 1 mole of zinc chloride on the top. And guess what, guys? We are done. Now we just have to do the math. 2.6 times 1 times 1 is 2.6. 36.46 times 2 is something, and you're going to tell me. And what is my answer? What's 36.46 times 2? 72.9. And on top here I had 2.6. So somebody's going to do that math for us, and then we'll have our answer. And remember, we just went from grams of one thing to moles of a totally different substance. And we use the molar mass and the mole ratio to get it. And what's my answer? 0.03 moles of zinc chloride. Very, very good. We're going to go from grams of one substance to grams of the other substance. Here in this problem, we stopped where? At moles. And we had our answer. And in order to go from grams to moles, you told me we use the molar mass. So what do you think we need to use to go from moles to grams? The molar mass. Very good. Now this time we're not using the molar mass of HCl. We're going to use the molar mass of who? Zinc chloride. So I'm going to put my 1 mole of zinc chloride on the bottom. And I'm going to put my grams of zinc chloride on the top. You're going to multiply 35.45 times 2. Somebody, thank you. And then we're going to add zinc. Huh? It is. And then now add zinc's weight to it for me. What is it?
136.3.
136.3 is my molar mass for zinc chloride. So now we have to do the math again. 2.6 times 136.3 divided by that number that Anaya said earlier, 79 something. 72.9. And we will then have the grams of zinc chloride for our answer. Is what? 4.86 grams of zinc chloride. Woo! You went from grams of hydrochloric acid to grams of zinc chloride. Stoichiometry. Say it.
Stoichiometry.
Louder.
Stoichiometry.
Stoichiometry.